I'm a plant geneticist. I study genes that make plants resistant to disease and tolerant to stress. In recent years, millions of people around the world have come to believe that there's something sinister about genetic modification. Today, I'm going to provide a different perspective. First, let me introduce my husband, Raul. He's an organic farmer. On his farm, he plants a variety of different crops. This is one of the many ecological farming practices he uses to keep his farm healthy. Imagine some of the reactions we get. Really? An organic farmer and a plant geneticist? Can you agree on anything? Well, we can, and it's not difficult because we have the same goal. We want to help nourish the growing population without further destroying the environment. I believe this is the greatest challenge of our time. Now, genetic modification is not new. Virtually everything we eat has been genetically modified in some manner. Let me give you a few examples. On the left is an image of the ancient ancestor of modern corn. You see a single row of grain that's covered in a hard case. Unless you have a hammer, teosinte isn't good for making tortillas. Now take a look at the ancient ancestor of banana. You can see the large seeds and unappetizing Brussels sprouts, an eggplant, so beautiful. Now to create these varieties, breeders have used many different genetic techniques over the years. Some of them are quite creative, like mixing two different species together using a process called grafting to create this variety that's half tomato and half potato. Breeders have also used other types of genetic techniques, such as random mutagenesis, which induces uncharacterized mutations into the plants. The rice in the cereal that many of us fed our babies was developed using this approach. Now today, breeders have even more options to choose from. Some of them are extraordinarily precise. I want to give you a couple examples from my own work. I work on rice, which is a staple food for more than half the world's people. Each year, 40% of the potential harvest is lost to pest and disease. For this reason, farmers plant rice varieties that carry genes for resistance. This approach has been used for nearly 100 years. Yet when I started graduate school, no one knew what these genes were. It wasn't until the 1990s that scientists finally uncovered the genetic basis of resistance. In my laboratory, I isolated a gene for immunity to a very serious bacterial disease in Asia and Africa. We found we could engineer the gene into a conventional rice variety that's normally susceptible. And you can see the two leaves on the bottom here are highly resistant to infection. Now, the same month that my laboratory published our discovery on the rice immunity gene, my friend and colleague Dave McKill stopped by my office. He said 70 million rice farmers are having trouble growing rice. That's because their fields are flooded. And these rice farmers are living on less than $2 a day. Although rice grows well in standing water, most rice varieties will die if they're submerged for more than 3 days. Flooding is expected to be increasingly problematic as the climate changes. He told me that his graduate student, Kenong Shu, and himself were studying an ancient variety of rice that had an amazing property. It could withstand 2 weeks of complete submergence. He asked if I would be willing to help them isolate this gene. I said yes. I was very excited because I knew if we were successful, we could potentially help millions of farmers grow rice even when their fields were flooded. Kenong spent 10 years looking for this gene. Then one day he said, "Come look at this experiment. You've got to see it." I went to the greenhouse and I saw that the conventional variety that was flooded for 18 days had died. But the rice variety that we had genetically engineered with a new gene we had discovered called sub1 was alive. Kenong and I were amazed and excited that a single gene could have this dramatic effect. But this is just a greenhouse experiment. Would this work in the field? Now I'm going to show you a 4-month time-lapse video taken at the International Rice Research Institute. Breeders there developed a rice variety carrying the sub1 gene using another genetic technique called precision breeding. On the left, you can see the sub1 variety, and on the right is the conventional variety. Both varieties do very well at first, but then the field is flooded for 17 days. You can see the sub1 variety does great. In fact, it produces 3.5 times more grain than the conventional variety. I love this video because it shows the power of plant genetics to help farmers. Last year, with the help of the Bill and Melinda Gates Foundation, 3.5 million farmers grew sub1 rice.